Can you now see it?
Yeah, good to see it.
All right, great. Hello, everyone. Welcome to this final session for Automated Market Maker. So we're going to run through the coding for how to create an automated market maker. So I've gone a little bit ahead to build up the code, but you do have a bit where you participate later on. So the first thing we need to do before we start is to create an IERC20.so contract in Remix, right? Just trying to open it up so that you can get a see of the code. Because the IERC20 defines the tokens that we're going to be using. You're going to declare tokens into the contract. Yeah, so there we go. So for those of us that are quite familiar with the IERC20 token contract, this is how it looks like. If not, you could get a sample of this on GitHub or any of the other repository that you know about, right? So you go about so the interface for the IERC20 is you declare it after you declare your pragma solidity and also your SBDX license identifier. The total supply function, which is external view, returns a uint. Also the function balance of the address is an account. External view returns a uint. The transfer for the token, right? Function transfer. The address is a recipient. The uint amount. External returns a bool. Function allowance. You also see the address is the owner. The address is also the spender. External view returns uint. Then the function approve for the address spender, the uint amount, external returns bool. And so this is just a basic IERC20 token contract you could get. So after you build this, right, you now then import that into your constant product automated market maker. That's what we're actually building here, right? So you import the IERC20 token soul, right, into the contract, right, into the automated market maker .so, and then you declare your contract CPAMM, which is constant product automated market maker, and then you now declare your tokens, right? So these are the two tokens, and because you're going to be using token 1 and token 2, token 0 and token 1, which is your X and Y, right? And they don't change throughout the contract. They are public and they are immutable, so they don't change, right? The next you need to do after you declare your immutable tokens is to declare your constructor, right? Yes, I know you see public reserves here. We'll get back to that. You declare your constructor, and then in your constructor, you put your address for the token 0, just as we have here, and address for token 1, just as we have here. Then token 0, you declare it as an IERC20 token, right? Sorry, let me sort that out. Right, okay, so that's one line here. So, so you have a token 0 IERC20, right, and a token 1 IERC20. Then after you finish with your constructor, you come back and you have to also come back and declare a uint for the public reserve for token 0 and for public reserve token Y, basically X and Y, right? Then you declare a public uint for a total supply, public total supply, and then a mapping, right? So you map it to address.uint and then public balance of. So after you've done all this, you come over here, right? To mint, you come to function mint to mint out your tokens, right? So the function mint, you have address to, and then the uint also an amount, and this is a private. This should be private returns, a private function. So this is a private function actually, right? And then you have a balance of to which is an increase. This is an increase, and also an increase in total supply. The amount of the balance and the total supply that will be minted of the token, right? So function bond will be the next you declare, because this is to mint and this is to bond the token as well in the AMM, right? So you, again, address is, this changes, what you declare here is different. This is changes to address from and unit amount, right? And instead of having an addition here, this is a subtraction, right? So every time you bond a token, it's a subtraction. Then you update your reserve. You need to update the reserve. So you have function update, uint, update the reserve 0, and then uint reserve 1. Basically, as we have here, reserve 0 is for token 0, reserve 1 is for token 1, right? So this this area completes the initial area of the contract. Then we go to swap functions, and we go to liquidity function, adding liquidity function. So the code for function swap, right, is as you have seen here, you have function swap, and the address is token in, and uint amount, uint is amount in, right? And this has to be an external returns because you're swapping, right? And that means you have to get something out. So this is for the token that goes in and the amount that goes in, and then you have to get an amount that comes out. So this will now take the require function for token in equals to address token 0. This is token X, or the token in is also equals to the address of token 1. So if not, we return the query that no token was supplied, which is the invalid token. And then we now have the required function to be amount in is greater than 0, and if we don't get the amount to be greater than 0, then you have the query amount in is 0. So that's that. Then to pull in tokens into the contract, right? So we have this code here, right? We declare bool, and then we say is token 0 equals to token in is equal to the address of token 0, which we've declared over. And then we have the IERC20 token in and IERC20 token out, right? With uint reserve in and uint reserve out, right, is equal to token 0. And so if we don't, so this function is to help put in the token into the contract, right? And then we can now say if the token in contract, if the token is transferred, right, from message.sender, then you say the address of this contract, right, is equal to address of this contract for amount in, right? Please, if there's any point in time in this series that in this class that you fail to ask me a question, please go ahead. Then we have to calculate the amount for token that goes out and include the fees for 0.3%, which is actually a slippage fee value, and that will be taken on by the AMM, right? So initially, remember in lesson 2 when we discussed about the AMM formulas for calculating token out, right, for the constant AMM, right? We had this formula y dx divided by x plus dx is equal to dy, right? So this is what we're trying to implement here. So we basically say uint amount in with fees, which is what we're trying to say, and then equals to amount in multiplied by 997 divided by 1000. So basically we're trying to say 99.7, right, of the token that comes in, right? And then we'll remove 0.3% from this. So, right, so amount out is equals to reserve out multiplied by amount in with fees, right? This is the fee divided by reserve in plus amount in with fee. So for transfer of the token out to message.sender, we basically say token out dot transfer message.sender amount out, and then we update our reserves, right? Which is every time you have a calculation, every time you do the swap, right? The reserves get updated automatically. So to update the reserves, you have update token.0 balance of address this of this contract, and for the token 0, and then for token 1, you have token 1 balance of address of this contract. So this completes the swap function of this contract. Then we'll move on to add liquidity, right? And for the function of add liquidity, you have, of course, the unit amount of token 0 and unit amount of token 1. And these are external returns. And then we return out shares, because we are every time you add liquidity, you get shares out for adding that liquidity. So again, we pull in token 0 and token 1, right? So which is why we have token 0.transfer from message.sender address this and amount of 0, and then token.transfer from, right, message.sender address this and amount 1, again for token X and token Y, right? So again, pay attention to this formula, because this is what we're trying to implement down here, right? So we'll now go to if the reserve is equal to 0 or reserve is greater than 0, right? Then we require reserve, sorry, this is greater than, not equal. We will require the reserve multiplied by the amount 1 is totally equal to reserve 1 multiplied by amount 0. If not, this function gets declared, which means dy dx is not equal to y over x. Basically, y and x is not equal to what we have inside this contract. Then we now go on to mint our shares. Now, also going back to the introduction for the constant AMM formulas, to mint shares, remember we said in the formula that f of x and y is equal to the value of liquidity, and then we square it of x and y. So s is equal to dx divided by x multiplied by t, right? T will represent the tokens that are going to be minted, right? Is equals to, and S is actually the shares, right? For those who don't remember the formulas. And then we have dy all over y multiplied by token, total amount of token. So y represents token 0, x represents token 0, y represents token 1, right? So if total supply is equals to 0, then the shares of the square root amount, right? We multiply that by amount 0 multiplied by amount 1. Else, the shares to mint is equal to, we have the shares and we mint, right? Before we even do this, we have to also get the square root function, which is what you see down here. Now, this is, you can actually see this on Uniswap as well, right? This has been declared on Uniswap themselves. So we just copy that from Uniswap, and then we come back, once we've done all that code, we'll copy and paste from Uniswap, we can now come back and mint our shares, right, for token 0, which is amount 0 multiplied by total reserve, total supply divided by reserve of token 0 or token X, and amount 1, which is token Y, multiplied by total supply, divided by token reserve Y, right? So we also require that the shares of shares that we get is greater than 0, or we declare the shares are not equal to, the shares are equal to 0, right? So we move over to message.sender. We declare the mint, message.sender for the shares, and then we update our reserves once again, just as we have as before. So as I mentioned, This was for function of adding liquidity and for swapping, right? I did leave remove liquidity function. If anybody can attempt that and possibly submit on today or tomorrow will be great, right? Or Monday. Monday will be a great time to submit. So this is where we get towards the end of this series. Any questions so far?
Yeah.
Hello.
Can you explain the underscore update function?
Sorry, I can't hear you.
Underscore update function.
I still can't hear you. Can you check your mic? All right, Augustine, go ahead.
Hi, everyone.
Hello, hello, hello.
I'm sorry that I didn't follow from the beginning of this series, but actually I just got to know about a few days ago. So I had some couple of questions, and I think I used the chat. In line 43, I really don't understand the use of the double equal to there. In it's a boolean of each token is equal to underscore token. Then we now have the double equal to again. I don't know what we're actually trying to achieve.
So you're trying. So for this here, we're trying to pull in the token, the first token, into the contract, right? And if you see, we have token 0, which is token X, and then so we say bool is token 0 equals to the token in, and the address of the token 0, right? Is in. So that is what this double equal is. Is it clear?
Okay. Okay. Then the second one, I think, is a typo error on line 82. I saw minimum. Is it minimum or mint? In line
sorry, that's
82.
supposed to be mint. Sorry, 82 should be mint. That is from me. Sorry, you're right.
Okay, sorry. I am a little bit more confused here. The token 0 and token 1.
Yep.
The token 0 address. I don't understand. Will address.this get us from the beginning? You said that our token 0 is immutable.
Yes.
And
both tokens are immutable. They are immutable. Yes.
The contract address for token 0 and token 1, is it the same?
Yes. Because it resides in the owner of the AMM, so it has to be one address.
Okay, so it means this current contract owns token 0 and token 1.
Yes. So I don't know if you've seen any of the AMMs in the market. Are you familiar with Pancake Swap or Uniswap?
No, I've not actually gone through, but I just
okay. So
that's why I said I should have followed the series from that. Someone just told me 2 days ago. So
token 0 and so token 0 and token 1 belongs to the owner of the AMM. And if you take a look at Pancake Swap or Uniswap, you'll see that there is a liquidity pool which token 0 and token 1 fills in. And then when you add liquidity or you remove liquidity, you are removing from that same address of the AMM. Is it clear now?
Yeah, but sorry for my curiosity.
It's fine. It's fine. We're all learning. We're all learning.
Okay. Because actually, I'm still trying to understand AMM. Does it actually mean that one cannot use an external token address, or must an AMM be directly a contract programmed by the developer for such a particular token? Assuming we have maybe token 1, maybe we'll say let's say 2 tokens die to token 1 could be die, token 2 could be let me use maybe USDC,
Okay.
for instance. And
So
we know that they have 2 separate addresses, maybe from whatever. Can we use their token address, or we have to hard code our own token in our own smart contract?
so let's take it this way. Imagine you being, let me use, you're from Nigeria, I presume, or right?
Yes, yes.
Okay. So let's use a Nigerian context to this. Bureau de change, right?
Yeah.
Remember the concept of bureau de change, right?
Yeah.
You go to bureau de change, you give them naira in exchange for dollars, right? You go to one bureau de change, right? And you give them money, right? Your own naira, and they give you dollars. Now imagine if now in the bureau de change value chain, you have, before the dollars get to the bureau de change, there's a bank that supplies the bureau de change, and then there is CBN that supplies the bank, right? That's the value chain. Now take it that there was no human interaction in that process. That means you're not seeing the physical person of the bureau de change manager or the bureau de change assistant, right? But there is a CBN or so and a bank who actually own a digital front, which is the AMM that we are interacting with. And so they have some liquidity that has been given to them because people like me and you give them tokens, and they say, okay, help us manage our money. In fact, help us and mint new tokens so that we can get shares from the transaction. Do you understand it?
Okay.
Right? So
okay.
You give them 2 tokens, and you say for the next trade, you want a fee given to you over the trade, 0.3%, 0.5% in some cases. For instance, on Pancake Swap, it varies between 0.3% and 0.5%. I've not tried Uniswap as well, but Pancake Swap it varies. So that is the fees that get paid to you for giving us your tokens to trade, right? It's like also if we remove bureau de change and we say fixed deposits in the bank, right? You give them money, and they say after 1 year they give you your money plus X amount added to it. Yes. So basically, just think of AMM as a bureau de change, or as a bureau de change, but without physical interaction, without the human interaction. That's the best way to look at it from a Nigerian context.
Okay. Yeah, I think it's clear.
All right. Great.
So the whole concept is all about submitting some capital as liquidity, and you as the one who invested is expecting some returns.
Yes, exactly. Okay. Exactly.
Thank you.
All right, great. Any other questions?
I don't know if there is any way I can maybe talk with you later. Maybe probably.
Yeah, I can. I'm Master Zion on Discord at Master Zion. Let me stop my share and share my tag name. So I'll just put it in the chat. You can reach out to me, and then I'm ready to chat with anyone.
Okay, please. I would like to connect with you.
All right.
Steven, can you show us like giving some liquidity and swapping tokens, like a small demo?
Sorry? Swapping?
Yeah, just a demo. Yeah, if it is possible.
From online, right? From an example that has been done already, let me go to, hold on, let me check on Pancake Swap. So one minute, please. Let me get onto Pancake Swap so that I can show you guys what it means.
Yeah, sure.
And before we get there, any other question about AMM?
Yeah, I have another question. Like,
yeah, you can. While my system is loading, you could go ahead.
Last week we were discussing about removing the liquidity from the AMM, right? And
Yep.
you also said that while adding a liquidity, we would just add a dx to the x of already existing. So while removing, the formula would be like x minus dx divided by y minus dy is equal to k hash, something like that, or there's a whole new concept.
I need to check the slides again. Let me take this first question, then we'll check the slides, and then we'll answer that question. All right.
Yeah. Okay.
So currently is so just trying to look for the function for on the website for swapping. I would have done this on my mobile, but my mobile is so much easier than on the online version.
Or else you can just share our links, something like that. If it is.
All right, so I'll give you guys links to Pancake Swap. You can try and connect your wallet and see, right? You'll be able to swap one token for another token on Pancake Swap, right? And see how it is. You see the slippage value, the amount of money, tokens you get, right? When you do a swap from either USDT to maybe price or to any other token that you have, right? So that's the address. You guys can play around with Pancake Swap. Now to answer your other question. One minute.
Yeah, sure. I'll go.
I need to bring something.